After creating your geometry in SpaceClaim, you can now move on to analyzing your bone structure. So this is what the mesh for me looks like, and I did this by creating two face sizes here, one with all the outer faces except for the sides, and then another face sizing that's only just the sides here. And it's important to note that as we zoom in here, because this is two different bone structures, two different materials, you want to make sure that you get enough coverage with your mesh. So a typical industry standard is to at least have two elements spanning the width of your material, which you can see here there are at least two elements for both materials. So you want to make sure that it's that defined on the inside and for the mesh itself. And once you have your results, once you solve it, you want to check that the results you have actually make sense. You want to make sure that it's not the garbage in, garbage out that Professor Bhaskaran is talking about here. So one way we can do this is by checking the boundary conditions. One of them is the total deformation here, right? So this is what our shape looks like, where the deformation is the rectangle that we specified. And if you remember correctly, we specified that the total deformation is 0.3 millimeters. And when we look at the max over here, it's in 0.3044 millimeters, which is close enough to the results that we want as well. And if we look on the bottom as well, we can see that the deformation of our cylinder only occurs after our initial boundary condition of these two rectangles here. Remember, these are the supports, so it doesn't make any sense for our cylinder to deform before these supports because there's no forces over there, and that's what you can see here. There's really not that much deformation, if at all. It's really small. So that makes sense. And you can do some more analysis such as strain as well as stress in different axes, X, Y, Z. You can change that just down here. And so that's kind of a way that you can analyze the results that we've been getting.